Okay, the space topic. It's all about redshift. It's all about the birth and death of stars. There might be the odd calculation they could chuck in. So I'm going to go through a few questions now, just as you prepare for your test. So question 1, the light from distant galaxies shows redshift. Complete the sentence. The term redshift describes the observed increase in the wavelength of the light from the distant galaxy. So remember, red is longer wavelength than blue. Red is lower frequency than blue. So remember your frequency and your wavelength. High frequency, short wavelength. Low frequency, long wavelength. So they might ask you in terms of frequency. They're more likely to ask you in terms of wavelength, to be honest. The Big Bang Theory, question B, is one model used to explain the origin of the universe. How does the Big Bang Theory describe the universe when it began? Well, it describes it as very hot and very dense. You've got to get fusion happening to form stars, remember. So all our elements are going to be formed by the fusing of small elements into bigger elements up to iron, remember. Anything beyond that forms in a supernova. So we'll come back to that later. Then we've got a graph. The figure below shows data scientists have collected from measurements of redshift. So we've got the speed of the galaxy away from the Earth in meters per second times 10 to the 7. So that would be 2 times 10 to the 7 meters per second, etc. And this is the distance from the Earth in terameters, which is 10 to the 12. We don't use that very often. We use it in space because its numbers are big. So tera is 10 to the 12. Remember that. That comes up again later. Describe the relationship between the speed of a galaxy and the distance. So in other words, it's asking you to describe a straight line that passes through the origin. And you know in all of physics, when there's a straight line that passes through the origin, like when you do Hooke's law and the force is directly proportional to the extension or extension directly proportional to the force, you've got a straight line through the origin, so it's directly proportional to each other. That's what we're looking for there. D, which of the following is the same as 6 times 10 to the 12 terameters? Well, tera is 10 to the 12. So you've got 10 to the 12 times 10 to the 12, which is 12 plus 12, which is 24. So 6 times 10 to the 24. So remember all your powers of 3. Okay, we've talked about that a lot in science lessons. So you will probably get a question like that with your standard form and powers of 3. Part E, explain how the data in the figure above supports the suggestion that the universe began from a very small region. And this is the answer you're always going to give for these questions. The furthest galaxies are moving the fastest. Let's have a look. The distance from the Earth, they're the ones that are further away. And look, they're moving faster. That's moving faster than that. That one's further away than that. So just describe what the graph is telling you. The furthest galaxies are moving the fastest. And it will usually be in terms of galaxies and how they're moving either away and showing redshift or towards and showing blue shift. And it also suggests that the universe is expanding from a very small point, and that's when the Big Bang started. So that's what we're looking for. About the fact that you know what redshift and blue shift are, and the fact that it suggests that it's expanding. The Big Bang theory suggested that gravity would slow the rate at which galaxies move away from the Earth. New observations suggest that distant galaxies are moving away from the Earth at an increasingly fast rate. So the ones that are further away are actually moving away at an increasingly fast rate. What do the new observations suggest is happening to the universe? Well, if they're going away at an increasingly fast rate, it suggests that it's expanding at an ever greater rate. Okay, so the rate of expansion is increasing. That's what that suggests. New observations and data that do not fit existing theories should undergo peer review. Remember, you've got to understand this term, peer review. It's when other scientists that are as good as you get together or just do your experiments and look at the data and decide, actually, no, that's good science. So give one reason why peer review is an important process, and you can tick any of these. And this is just good to revise what peer review is. It can detect any false claims. Okay, it can detect any inaccurate data. It can detect any bias. It can verify the new data. So check your validity. And it can provide a consensus. Yeah, we all agree this is good science. Let's change the theory because this new evidence is actually explained in a better way. Okay. The Andromeda galaxy is moving towards the Earth. So this is going to show blue shift, not red shift. Describe how the wavelength and frequency, so there you go, you've got to know your match of wavelength and frequencies. Describe how the wavelength and frequency of the light from Andromeda seem to have changed when viewed from the Earth. So it's coming towards, which means you've got blue shift. What does that mean? It means the wavelength has decreased and the frequency has increased. Okay, remember your blue is short wavelength, high frequency. So if it's gone bluer, the frequency is increased and the wavelength has decreased. Okay, that's question, I'll just do one at a time, but a lot of these questions are going to be about redshift. So just have a look at the other ones and you'll see what I mean.